Hey guys, it's Miss Farmer. Okay, so we are going to go over that Unit 4 review. This is completely optional. It was just a video in case you guys wanted some explanation about why answers are what they are. I'm going to let you know ahead of time. I can only record for 15 minutes at a time. So if any reason it stops, I'll have another video, just so you know. All right, so this should be number 1. If I can write on this, it'd be wonderful. Come on, computer. You were doing great 5 minutes ago. All right, so this is number 1 for you. All right, so which equation is graphed? So we have this, we know it's a quadratic, and then I look at my A, B, C, and D, and I'm like, okay, there's two things going on. A and B are in vertex form, and C and D are in standard form. So I have to figure out kind of what information each form gives us and what information is on this graph. So when it comes to when it comes to vertex form, the easiest thing to find is the vertex. And it doesn't really look like there's a vertex because you're like, well, where is K? But it's there. It's behind it. So the vertex of A is -3, 0, because remember, it's the opposite of whatever falls in here. The vertex is at -3, 0. So I'm going to look at here. Is my vertex at -3, 0? And that's a no. So it can't be A. Vertex form of B helps us out because that vertex is 3, 0. So I'm like, all right, so let's see if the vertex is there. 1, 2, 3, nope, that's not it. So this can't be it. So now we're down to C and D. And you're like, okay. So now I'm not in vertex form, so it's not as easy to find the vertex here. This is standard form, which is that ax squared plus bx plus c. And standard form, the easiest thing it gives you here is your c, and that is your y-intercept. So that's the easiest thing to find when it comes to standard form. Now, I know this doesn't look very similar. You're like, well, hold on a second. These are only 2 terms, and this one's supposed to have 3. It does. It's just b is 0. So that -3 right there, because it's a constant, it's by itself, it doesn't have an x to it, that's the y-intercept. So it's saying that my parabola should have a y-intercept of -3. So when I look at -3 on the y-axis, oh, I do. That one does have a y-intercept of -3. So C is definitely a possibility. D has a y-intercept of +3. Well, I know this parabola doesn't have one of +3 because it has -3, so it has to be C. The thing to take away from questions like this, in one question, oh, I'm moving stuff, look at me. In one question, you not only have to know how to graph a parabola, but you have to know the strengths and weaknesses of vertex form versus standard form. So I hope that question kind of answered that. You have to know both. So that was number 1. All right, so let's go to number 2. What are the x-intercepts of the quadratics? The first thing you need to know, or what in the world are x-intercepts? X-intercepts are where it crosses the x-axis. And it kind of makes sense because we know what a y-intercept is. It's where it crosses the y-axis. So an x-intercept is where it crosses the x. So I'm going to go ahead and skim the x-axis. It doesn't cross. So if it doesn't cross, then there are no x-intercepts. That one's pretty easy. All right, let's look at this same kind of verbiage, the question. We just have to figure out where it crosses. What are the x-intercepts? So right here it crosses the x-axis here. That's number 1, and it crosses here, number 5. So it must be B. That it crosses at 1 and 5. This is number 4. So this again is what we did just like question 1. Gives us a parabola. It gives us 2 in standard form and 2 in vertex form. We got to figure this out. So in standard form, remember we talked about the strength of standard form is the y-intercept, and it says that it has a y-intercept of 1. So when I look at my parabola and I go to 1 on the y-axis, it does have a y-intercept of 1. So it could be A. We can't eliminate A just yet. All right? So B, this has a y-intercept of -1. Look at me. We know that's not true. So we know it can't be B. That's a goner. All right. This right here, this is in vertex form down here. So we have to figure out here if this vertex is 1, 0, because this is a +0 at the end of it. So this vertex is -1, 0. Oops, forgot my parenthesis. All right, at 1, 0, there's no vertex there. It can't be C. All right, at D, -1, 0, that is the vertex. So we're like, All right, so we are between A and B, or A and D. Somewhere in here, it's going to work. So let's go ahead and plug in some numbers to see where it is. And what I do is I can make them up. So, look at here. I'm going to draw up this parabola. I'm going to try to find another pretty point, like that one. So here, x is 1 and y is 4. So I'm going to see if that works. So I'm going to bring down the letter A. I'm going to try it. If y is 4, will that be 1 squared plus 1? All I did was I changed that y to 4 and I changed that x to 1 because at that point, x is 1 and y is 4. So 4 equals 1 plus 1. 4 does not equal 2. That doesn't make sense. So let's try it with D. Let's try that. Does 4 equal 2 plus, oops, I'm sorry, let me erase. I'm going a little, I'm trying to click the button. So sorry, it's supposed to be a 1. Does 4 equal 1 plus 1 squared? We'll do parentheses first. 4 equals 4. That is true. So it has to be D. D is the right answer. All right, so let's keep going. This is number 5. Which graph matches the equation? And I'm going to apologize. These are like the smallest tiny little tiny graphs. But when you are in USA Test Prep, when you hover over them, they get bigger so you could see them more easily. But just for these purposes, they're just tiny. So whenever I do something like this, I look at my answers. I'm like, all right, let's see the difference between them, things like that. So, and then I say, let's look at this. This is in standard form, and I know it doesn't quite look like it because B is 0, so that is why he's gone. So the first thing I look at is this negative sign. So my parabola should be facing downward, should open up downward, and all of them do, so I can't eliminate any that way. Now, when it comes to standard form, its strength right here is the y-intercept, and that should be at 2. So I'm going to go to letter A. He does not have a y-intercept of 2. B does, C does not, and neither does D. I don't have to do a single shred of math as long as I know the strength of my standard form. And that is that the y-intercept must be at 2. So it has to be B. Alrighty, number 6. Okay, this one is a little bit different. It's not in standard form, it's in vertex form. And I'm going to write it down here just because I can. Negative, wow, that's not, let's just ignore that. Y equals negative x minus 2 squared. And I'm like, hold on, where's my k? Well, it's just plus 0, and I'll put that there. So the strength of this one is vertex. If it's in vertex form, my strength is my vertex. And it's 2, 0. So I can go through and figure out which one of these has a vertex of 2, 0. A, that's negative 2, 0. B is 0, 2. Nope. Nope. It has to be D. Don't you like these? So again, if you know the strength of vertex form and the strength of standard form, you don't have to do much math. It's the best part. All right. Let's look at this. This is a transformation. Now, when it comes to transformations, what we have here is this is the equation. It's in standard form. Again, b just happens to be 0. And we have to move the graph up 6 units. So if we are just moving it up and down, when we're just going up and down, the only axis that's going to really affect is the y-axis, because the y goes up and down. Another thing that we knew, that in standard form, this guy is our y-intercept. So we know if we're going to move it up 6 units, my y-intercept is going to increase by 6. So you can either add 6 to this number, which turns it into a positive 3, or we can straight up just count. From our vertex, we're going up 1, 2, 3, 4, 5, and 6. My new vertex is at 3. So when you look at this, your only option is A. Okay. When it comes to something like this, when you see numbers in front, so y equals, this is a parent function, pretty much. It says, which is the widest? So we're looking at numbers that go in front of x. And I'm going to tell you kind of how I remember it, is if you have something, a bigger number in front, if these numbers are increasing in front of it, that's kind of like increasing the amount of people that are pulling on your parabola. So like this is a graph, right? And this is my parabola. If I have 2 people up here, 2 people, and they are pulling on my parabola like it's a rubber band, right? They're pulling on it. It is going to stretch it, and it is going to make it skinnier. The more people pulling, the skinnier it's going to get. So you were looking for something that is between 0 and 1. That widens it. That's a fraction. So between 0 and 1, these are only 1/4 of a person. They're going to actually fatten it. So when it says the widest, you're looking for something with a fraction. Okay, so number 9. All right, when we have something like this, when you look at it, it looks a little different. You're like, gosh, it's so close to vertex form, but it's not really vertex form. And it's probably because these numbers over here with y, they're the ones that are kind of bothering you. So what you have to do is let's move into the other side. So we're going to subtract 1 from both sides, and we come up with y equals 3x plus 2 squared minus 1. And we can do the same thing. This one we're going to add 1 because that's the opposite. You get the idea. So once we do that, once we're moving all these to the other side, now it's in vertex form normally, and you're like, oh, okay, first thing I'm going to do is find the vertex. So this one has a vertex of negative, if I can write today, negative 2, negative 1. So if I go, and when I look at this graph, it is a little funky, but I'm going to go over to negative 2. These are actually in halves. These lines are in halves. Negative 2, negative 1. At first I thought this was negative 2, but I was like, oh, no. See how it's kind of, they're in halves. So this is negative 1. So my vertex is at negative 2, negative 1. It must be A. When you go through, it's not going to work anywhere else, because this will turn into 2, 1. This is negative 2, 1. It's not going to work, I'll tell you that. But you just had to move that number to turn this into vertex form. All right, so this video I'm at the end of. It's not going to let me record anymore. So we're going to label this part 1. I stopped at number 9, and then I will start number 10 in the next video.